Hey, welcome everybody. This is the first breakout session continuing the theme from this morning on rigorous, responsible, and reproducible science in the era of fair data and AI. We have 8 speakers. We're going to go through them quickly, and we'll have time for a couple questions at the end of each speaker. So let's just jump right into it. Our first speaker is Fernando Aguilar Gómez.
Okay, thank you. Good morning, everyone. I come from the Spanish National Research Council. And, well, we have a problem with the remote sensing data. Actually, it's not a problem because we have a lot of them, but sometimes it's not easy to reuse. So in this project that is called Goyas, we are trying to do all the workflow of publishing data in a fair by design way. So let me check how can I, okay, good. So the amount of data that is available on Earth observation and remote sensing is, well, increasing. We have a lot of instruments like drones that fly to get a lot of data. We have satellites from different missions, from European, American, or any other country missions. And it is an opportunity for different fields like to study and to monitor the climate change, to manage the biodiversity or any other resources. And we have a challenge. We are producing new data, derived data from those sources, but it sometimes remains underused without the fair principles. So our idea is to adopt these principles to publish, to facilitate the publishing of the data, because we as scientists, sometimes we develop a method, we produce new data, we publish a paper, and then what? Sometimes it's just in our laptops and it is not published. So can we facilitate the reproducibility of these methods and to facilitate the publication of new products based on those methods? And that's why we are developing our project Goyas. Well, we have also other problems like the complexity and heterogeneity of the different, at different levels, formats, volume of data, resolutions, the type of processing that we are adopting, and also different ones like, for example, the application of artificial intelligence to develop new data products. What we want to do is to get all the information that we have, that we are using to develop a new method, and to enrich the metadata with all the information of that to improve transparency, for example, and the reproducibility. And on the other hand, also with better metadata, we are capable of making the data AI ready, providing a lot of details that allows algorithms to get the knowledge to run and to process all the data. There are a lot of official data portals like Copernicus or Digital Earth Australia, etc., and that kind of things. And to publish a data product there is sometimes complex because, you need to do a kind of process, protocols. And for some specific products like innovative or more local data products, it's complicated to do it. So we are focusing in another type of repository. The type of products that we are developing, some of them are based on AI, like, for example, water quality parameters on specific water reservoirs, satellite-derived bathymetry, and also another ones like oceanography data products like salinity, temperature, or inundation maps. Goyas, that means Geospatial Open Science Yielding Applications, tries to bridge the gap for experimental and local data and for those bigger data portals. It is developed within OSCAR's project, that is a European project connected to the European Open Science Cloud. And we are focused on that kind of data products, like, for example, very innovative, using AI, some experimental. But even if sometimes it's not the best product, we want to add more transparency in order to allow potential users know every single detail, like accuracy, uncertainties, to let them decide if it is useful for them or not. And it complements large infrastructure like Copernicus by making smaller scale products. In one hand, we trust in metadata to do it fair, to improve the reproducibility, the transparency. And well, we're adopting one of the geospatial standards, like ISO 19139. And we want to do it in a fair by design mode. That means that from the beginning of, in the moment that we are producing the data, we are taking into account the fair principles in order to provide with any single detail about how we are producing the data in different types of metadata. For example, descriptive metadata, where we will include the persisting identifiers of different components, also descriptions of the data set, like the variables and that kind of things. We are also adding administrative metadata, some details about the provenance, for example, the connection with the paper that have been published explaining the method, or if can be better, the repository where the code that process the raw data is with persistent identifiers, and also structural metadata related to the formats, encoding, or that kind of things. To do so, we want to support the data producers and to facilitate the automation of all the process. So we are designing and we are implementing a pipeline that whenever a new event, that means a new product is available, it starts filling a new metadata version. For example, we try to publish the data in a OGC standard way that helps the connection to the data. We fill all the metadata related to FAIR, like, for example, coverage, the provenance, and that kind of things. We connect with our system that is based on GeoNetwork, and it is published automatically. And whenever everything is ready, it can be used by other people. We are on the last step. We are developing a fairness and integrity test that checks all the things in the metadata and also the adoption of the FAIR principles. And only whenever everything is checked and everything is okay, we publish the data with a persistent identifier assigned, so it can be cited and we can reuse it. Also, we have a kind of demonstrators that uses the data that is available in our repository, and with some examples. For example, for bathymetry, we can develop maps on when the ships need to go to a port, and any other things. Those demonstrators are based on Jupyter, so the idea is to help or to inspire others on how to use our available data. Also, we are focused on data producers, try to help them to automatically ingest the data. And with this pipeline, everything is published automatically, just filling a config file and pushing the data in some folder, and everything is running in the pipeline that checks every details. And whenever it is ready, it is published. And we are connecting with infrastructures like Embry to improve the visibility and to be aggregated in other systems to facilitate the access. In general, the type of users that we want to reach is, on one hand, researchers to access and publish the fair interoperable geospatial data and to enhance also the reproducibility. Also, environmental scientists to use the data that is available in our repository, specifically for different fields like climate, biodiversity, water quality monitoring, and that kind of things. And also policymakers or administrations that using our innovative data, they can take decisions. For example, one of our data sets is from the Gnana National Park. It's an inundation data set, and it is already being used by the authorities to take decisions about the management of this national park. And that's all from my side. So just remark that the idea is to think unfair from the very beginning of the project, so you can take decisions for that. Thank you.
Thank you. We have time for a question or two. Any questions? Yep.
Thanks for a great talk. The last slide you said that some of the users were over on the policy side of things. Did you have to do anything in the previous slide to that? Did you have to do, where would they interface? How would a policy user interface? Do you expect them to use the Jupyter tools, or have you had to make anything in the tool set that's a bit more accessible for different types of users?
Mm-hmm. In this case, we are using Jupyter because you have like different levels of the things that you can do. You can do just scripting and put the code, but you can add widgets or dashboard that help let's say no skilled people on programming to see the data and to configure things to change the view. So we think that Jupyter has the potential to be adapted to different types of users. So that's why we have selected that technology.
Great. Well, thanks you, Fernando. Our next speaker will now turn to the health field is Becky Grady.
Move this way down. All right. Hi, everybody. My name is Becky Grady, and I am here presenting a project about looking at using large language models, or LLMs, to draft data management plans. The primary bulk of this work is being done by my colleagues Nahid and Bhavesh, who unfortunately cannot make it here today, so you're all stuck with me presenting. All right, and so where are we coming from? I'm from the California Digital Library, which is part of the University of California, and I work in particular in the UC Curation Center, focused on adding value to digital research data. I'm the product manager for the DMP tool, which is why I'm a part of this project here. And Nahid and Bhavesh are from the FAIR Data Innovations Hub. This is part of the California Medical Innovations Institute, and they're developing open source software to help researchers make their research outputs more fair. All right, so why are we exploring this topic at all, using LLMs to draft data management plans? The main reason, people don't like writing data management plans. If anybody was in the Activating DMP section yesterday, we had a very engaging conversation just about all the problems people have writing these and how much people would like something to change, how much burden it takes to write a data management plan for your application. On the other side of this, large language models have been getting better at technical writing, and we know a lot of people are using them already for scientific writing in different contexts. So there have been many studies trying to look at large language models. GPT-4 tends to be the benchmark that people are going against. It has often shown the best performance. But many open source models like Llama 3 have also been showing a lot of success. And so this project started by trying to envision a use case of using LLMs to draft data management plans from simple, structured input from researchers. This started again from the FAIR Data Innovations Hub, where they have a lot of researchers there who wanted more help writing data management plans. And so the concept there is you have a researcher who's applying for a grant, and they have to write a data management plan, and they've already written a lot about their methods, they already know what kind of data they're going to collect. Can they use some information that they already have, feed it into a large language model, and get a draft that's ready to review and edit and accept? And so this is what we're trying to work towards eventually. At California Digital Library, our approach to generative AI overall, we have a couple principles that we want to follow that I think apply well to this use case. So we want to focus on solving real user needs, which we think that we're doing here. And our goal is to keep the human as the authority and to complement human work. We're not trying to get to a spot where we're fully automating. Somebody last night at the session said about AI to use it to augment, not automate, and I thought that was a great way to put that succinctly. And then finally, as a place that cares a lot about open source and open science and best practices, we want to be using open source models wherever possible. All right, so our preliminary investigation, this project is very early, so we're still very much in development of this tool. Our first step is to evaluate large language models off the shelf. So we wanted to see how good, with very little tuning, with little support, with just kind of off the shelf models, can we give it a couple prompts and see what it does, as a baseline for how good that starter DMP is. So for this first phase, all we do is use a prompt into, again, these off-the-shelf large language models. We're comparing Llama 3, which is an open source model, and GPT-4, which is a closed model and is more of a benchmark. And so, you can look up these slides later. I'm not going to read off the whole prompt here, but it has very minimal information about, where the person is applying to, what the study description is, and what data they're generating. And what we did for this first phase was we take the example DMPs put out by NIH. We extracted a couple the information for the prompt from there, like what the research data is, and we put that into the prompt and then fed that into the LLM. And then we have a DMP at the end generated by the LLM, which we can then compare back to the exemplar DMP from NIH. So the first step was just to see how similar it is. All right, we've got two DMPs generated from the same study design. How close are they? And so this was done with something called an expert similarity score. And very good semantic similarities around 80% or higher. And we see, okay, some sections are above 80%, some sections are a little bit lower. But importantly, this is not really a final answer here, because a different score, something that's not super similar, it could be a worse data management plan, it could be an alternate choice, but that's still fine, or it could be better. So we know that having it being similar or not is not the final answer. We really needed experts to review these DMPs. We all know that AI output can often look legitimate and look really great at a glance, and that doesn't say if this is really good quality. So we are currently running a survey about having people, primarily data librarians who regularly review DMPs, get 3 DMPs and then rate them. So they have one that's generated by a human from the NIH exemplar, and then 2 that are generated by LLMs, 1 from each model. And importantly, they don't know which is which. And they rate the DMPs section by section on what the quality is and what types of errors, if any, they see in that section. At the end, they give an overall score for their satisfaction with that DMP, and then they guess if they think it was written by a human or an LLM. So I'm going to pause just for a minute. I let people read this. I'm going to do like a quick little quiz about which one you think is human or generative AI. I picked this fairly randomly. I know it's a little bit long. Hopefully you're reading and not listening to me. And so I'll let this go for about 30 seconds, and then I'm going to ask people to raise their hand about which one they think is generative AI. All right, raise your hand if you think the left was written by generative AI. All right, and now raise your hand if you think the right was written by generative AI. I can't see super well in these lights, but I'm going to say this is pretty close to 50-50. There's definitely a lot of people for each one. And in this case, the left was generated by generative AI. What I think is interesting is all of this information about the repository and the identifiers and the access, none of that was fed into that. All of that just came from this off-the-shelf GPT model. It picked similar repositories. It picked different identifiers, even from just a very, very simple input. So now looking at the survey ratings is kind of the meat of it. This is still ongoing, so this is from the first 20 participants. We're hoping to get a little bit more. But you see the overall satisfaction was pretty similar. I haven't done statistical tests, so I'm going to really try not to say the word significantly. And the satisfaction was a little bit higher for LLMs, but pretty similar, and the average error count was lower. And people were at about chance level of guessing which one was human and which one is LLM. People were not particularly accurate at that. But there were very big differences between the large language models in this. So as you can see here, satisfaction with GPT was higher and the errors were lower. And so the GPT written DMPs were actually rated better with fewer errors, and 85% of people thought that was the human written DMP. If we go digging a little bit more into the types of errors that people saw, you can see that everybody, the humans and the llama model struggled most with clarity and completeness. And so that really helps us figure out as we continue development, where do we need to target making these large language models better? What are the errors that we're likely to see? And humans tended to be kind of in between the two, in between llama and GPT. All right, so next steps. We want to improve our generation models, especially for open source models. Again, this was always meant to be the baseline. We're never intending to just take an off-the-shelf model and, generate a DMP and say we're done. The goal is to figure out how we can improve and what are the areas that we need to target. What are the questions that we need to ask to make sure the researcher is really thinking about their plan? What are the types of strategies to make the AI better? Should we be generating section by section? These are the things we want to think about, and we still want to, our goal is still to use open source models. The fact that GPT-4, did perform pretty well tells us that LLMs can potentially get there, but we might need more support for open source models. We're going to continue to prototype and test this out. Right now we're still very early in the testing phase, but eventually we want to build a beta application where people can put in their study description and get a DMP, and we can get wider feedback from people. And then finally, the important part is addressing community concerns around here. Obviously, we do want to make sure the human is the authority, and we're thinking about how we can design an application like this that still makes sure people are thinking through their plan, people are reviewing it, people are accountable, and really get people to do the thinking and the DMP to do the writing. So that is where we are right now. I'm going to leave this up while I answer questions. If you'd like to take the survey or be part of any future surveys, feel free to sign up here. This is just the DMP tool user research feedback panel in general, and this is where we're recruiting these AI surveys from right now. So I can take a couple questions, and please sign up if you'd like to take more.
Yeah, we have time for a couple questions. This is the question crew over here. Are you're okay? You're good. Great. Thank you.
Thank you. That was great. My name is Bernadette Highlandwood from QUT Center for Data Science. I'm curious. I sit on an HREC. And I wonder if people won't start using these to do their ethics applications, where I feel both with a data management plan and an ethics application, researchers have to think through and not through the problems on how they're going to engage and do things with, say, research participants or data sets. So how much automation is potentially going to wreck our ability to, as researchers, do good research?
I think it's a really good question and something I've thought about too. I think, in my view, we have heard from people are already doing this. They're using ChatGPT, they're throwing things in, they're getting things out. My goal is to develop a tool over time that asks the right amount of minimal questions that gets what they really do need to think about. And so, maybe we've just picked a repository here and maybe it picked the right one, but that might not be that means the researcher didn't think that through. And so I think I'm spending a lot of time thinking about what those structured questions should be at the start, so we can say, all right, these are the critical things we do need them to plan, and don't give them any AI output until they've decided that part. But hopefully we can take a lot of the burden out of just the generating the narrative or some of the extra details that aren't as critical as that plan that they make for themselves first.
Okay, we have one. Oh, sorry. Last question, I'm afraid.
Just a quick question about the models you used. So the llama model, did you run that locally, or how did you run it?
So I know they used a Jupyter notebook. I think they ran both of them the same way, and I think they ran it locally on a high-powered computer, but unfortunately I would need to check with my collaborators who are doing the actual running of the models.
So both models were run locally, GPT?
I'm not positive about that. I'd have to check with them, sorry.
Okay.
We're working on a research paper right now that will have a lot more detail about the methods, and if you reach out to me, I'm happy to find out and get you an answer.
Okay, thank you.
Thank you, Becky. Our next speaker is Raj Singh.
Hi guys, and thank you for having me here. I'm super excited to be part of International Data Week and this session. My name is Abhimanyu Raj. I'm working as a data ecologist with QCIF Sustainable Futures team. QCIF is a non-profit organization where we are enabling infrastructure for researchers. Today we're going to talk about a few points, how we are making modeling accessible for our users, and the challenges we come across when we're designing the model and how we are overcoming those. Before we begin, I would like to pay my deep respect for traditional custodians of the land mentioned where we are meeting today, and pay my and extend that request respect to all Aboriginal and Torres Strait Island people. Globally, biodiversity is declining rapidly, and in Australia, we are facing some critical threats. Habitat loss, invasive species, and climate change is one few of them. Sometimes we have multiple cases affecting the same ecosystem. On the right, you can see a graph from Threatened Species Index report, which is published by ONTARN, where you can see the mammals are taking the most of the hit. These models are helping us to quantify and also understand the scale in threatening processes and identifying key areas where it's getting affected the most. Well, in designing ecological modeling, we do come across some of the challenges, and I would like to pinpoint some of them here. Oops, sorry, did I go further? Oh, sorry. Sorry about that. So these challenges are come across when we have different researchers and different data systems are recording different types of data. We have quality differences, we have format differences and coverage differences, where often the modeling process is hard to collaborate or co-develop. We also need high computing power. Many of the researchers don't have that access, so often they have to run their local machine for days and weeks. We also need advanced coding skill and modeling expertise. Many of us don't have years of R and Python experiences. The complex ecological network is already dense, which just makes the problem a bit harder for young researchers to engage. Coming from field ecology myself, I have faced these problems personally when transitioning into ecological modeling space, many of which were covered by the platform when I joined on 2021 as a student. We are filling gaps by integrating thousands of data sets from trusted resources and standardizing the data formats and metadata information, which is ready to use just like plug and play. This saves our users from data wrangling and also searching time. Entire platform is cloud-based and cost-effective infrastructure. We have services like easy-to-access point-and-click environment and R or Python integration notebooks. On the top of that, we also provide trainings where users can grow their skills over time. By lowering this learning curve, EcoCommons is letting researchers to focus more on the science and less on the technical roadblocks. As I mentioned, we have two major types of services, which you can see on the right. I think, yeah, it's on the right, where you have a couple of data preparation notebooks and also some modeling notebooks. This gives our users to do flexible analysis and custom functions, building and testing new data, new workflows in those environments. On the left-hand side, we have a point-and-click environment where we have a point-and-click tool where you can select those data sets, which is pre-prepared and available on the catalog, where you can simply click on various different options from environment data sets to land use data sets, and even import species data from third-party services. You can also upload your own data and run models with one or many machine learning or statistical analysis, where we have you can use those models to share with your colleagues for input and use on your reports when it comes to for biodiversity indicators. These, Yep. So I have a quick demonstration of what this platform can do in a quick, under 2 minutes. We have a GLM model, which is generalized linear model, which has a bunch of outputs, and I'm showing 3 of them here, which you can see on the left. We have a species distribution map. On the middle, we have a response curve, which gives you the effect of each environmental indicator, how it is affecting the model, and how we can do some changes. And on the right-hand side, we have the ROC model performance curve, where you have to do comparison between different algorithms and different dataset groups. These models are being used in a range of applications, like or contributing to standardized workflows for national policymaking, even Queensland State of the Environment report, and building international biodiversity reports and publication as well. Out of all these applications, I have one which is quite close to my heart, where we worked with eastern bristlebird species, and we are focusing on the northern population here, where we have less than 40 individuals in the wild. These sites are often hard to access, and it's based around southeast Queensland and northeast New South Wales areas. We partner with BirdLife Australia and Australian government and have built this bird suitability map for this species. We cross-check the model performances and compare data set groups, which were to have the best model for picking and promising for the new promising sites. Many of these sites were not even surveyed before, so we were quite stoked and very shocked to find those outputs. This also enables experts to deploy acoustic sensors and have those surveyed to focus on and improve their resources consumption. This is a wonderful way to see where EcoCommons is actually demonstrating demonstrating and providing conservation strategies, and this just helps me to see this in a whole circle, how it is completing and into ground action. You can see the picture on the right where we have a BirdLife expert who is using the SDM output of EcoCommons to pinpoint the key area where to put those recorders. Looking closely and underneath the skin, I think we have this platform based on R and open principles like findable, accessible, interoperable, and reusable data and models. The workflows are scientifically validated from our Australia's top modeling experts, which are our scientific advisory committee. We have thousands of ready-to-use data sets and climate data sets, and we have 20 robust algorithms for distribution models, for ensembles, for climate change projections, and 400 terabyte of disk space, 800 CPUs for computing, which is available dynamically for our users to pinpoint to. On the right, we have our recent publication article where you can read more about this and all the methods, how we are making all of this possible. This naturally helped us to build more and more trust, and with trust, it comes down to building a community where we are all sharing and developing our workflows together. Our community consists of partnerships with governments, universities, research organizations, peer-reviewed publications were released, skill trainings and case studies which has been formed collaboratively. We have integration from national and international databases for species like GBIF, ALA. The notebook environment is giving open space for sharing code and co-evolve together. And the platform is giving options for sharing the data sets and models, which is more transparent and reproducible. Before concluding, I would just like to say the key strength of this project's longevity is community-driven collaboration and feedback which we get to improve the system for next generation of ecological researchers. I would like to thank our partners and collaborators and also our team and my colleague, which are working around the clock to make all of this happen. Thank you for your time today, and I'll look forward for the questions and connecting further.
Thank you, Raj. We have time for one quick question. Did you find any bristlebirds? She asked.
So, as we are speaking, all the recorders are already in place, and both New South Wales and Queensland government team are coordinating in between the teams, and they are actually recording all the session. We would know fairly soon, and we'll go all press, don't you worry. And it will be sometime, I'm guessing, around January when the whole survey is going to complete. I'm just crazy like how we are bringing two states together for a same species and conservation. So that was a very special moment for mine. Thank you.
Thank you, Raj. Yeah, good luck with that.
Cheers.
Is one here? Okay, great. I hope I'm saying your name right. Juan Miguelez. I think, here's your little advancer thing. I think this is your pointer.
No, that's
So you could use this to go forward and back, and that's the pointer.
okay. Hello, I'm Joan Miguelez. I'm from Barcelona, from the Barcelona Supercomputing Center. And today I'm going to present a project we have in our center. It's called AI Data-Ready Workflows for Social Science and Humanities. And the first question is why? Why we need this workflow? Basically, we need this workflow for three things. The first thing is avoid complexity for scientists. Scientists usually find complexity gaps in using AI methods, and even more complexity in using HPC resources, so high-performance computing resources. We are a high-performance computing center. The second one is engineers. Often we don't look at this part, but every scientist have complex needs, and this means ad hoc solutions for them. And these solutions could be complex to apply. So in parallel of this support to scientists, we need to adopt modern software engineering approaches to solve this. And my background is from software engineering, so this is my part. And we want to deliver modern results. Current best practices on validation, reproducibility, responsible AI, we all know that these are very important, but sometimes could be hard to follow by scientists, and want to automate as much as possible this. So here is our architecture overview of the workflows, and keep an eye on the numbers. This is for scientists, this is for engineers, and this is for results, and keep an eye on the numbers because they will follow us along the presentation, and I'm going to explain this diagram part by part. Let's start with the first one. Less complexity for scientists. Here the goal is easy, or not. It's just to avoid complexity for scientists. And how we do that? First, we have this scientist that comes with some data and some initial research question, and then they met with engineers. And these engineers, what they do? They propose some pre-processing requirements that are very important in our experience. They propose some AI methods. They propose some validation requirements. For instance, if you use LLM in your pipeline, you will need human validation, and a budget and delivery terms. And that's fine. That's more or less the usual thing. But the important point here is this red dot arrow, this red arrow, that means that we have to iterate over the research questions and iterate over the data we had just to reach an OK in that part. And when we are OK in that part, we reach to the method development and validation part. That is a part of engineers. Here, the engineers need to develop a method and compute the method in HPC infrastructure, use the AI model hub, and make some validations. We'll check it later. And here our approach is to apply model-driven software solutions. And that's somehow scary for people that are not from software engineering. Model-driven development is a major discipline inside the software engineering field, and basically it seeks to develop software based on visual models and conceptual models, and that's our approach. Here we want to develop a domain-specific language and develop common development patterns. And this is getting very technical, but I don't want to scare you. Basically, we have some pieces of code like parallelization algorithms, training loops, common operations in data that can be used for other engineers without any extra effort. And this is something that we are developing here. And also we have some code generation features. So every time we start a new workflow, we don't have to start from scratch. Engineers can use all these elements and can generate automatically documentation, and we can smooth their work. Also, we have an internal AI model compliant hub. Basically, you are sure that the AI models you are using are compliant at least with the regulation in Europe. And now it comes to the validation part. The validation are tricky because varies depending on the method you're using. For instance, if you use LLMs in your pipeline, you will need a human validation. Here, we focus on providing a pool of evaluators for a specific task, and this is a challenge. This is really a challenge because every task varies, and we want to ensure that diversity and representativeness are in the validation sample, but also in the validation team. It's one of the challenges we are facing with workflows. And then we come up to the results, and basically results means not only giving you the data and say, okay, thank you for coming. We want to go beyond and give you also rock rates, give you your data automatically annotated with AI-ready metadata, Rosanne, for instance. We have an in-house data platform, our Dataverse, and we also give you something that is called trustable validation proof. That basically is the part of the data that has been validated along the validation methods. And sometimes this is the most valuable part of your data. But if I want to understand something, I usually want to have an example. This is one of the first workflows we run. We have only 5 minutes, so I will show you only one example. Basically, we try to analyze the entire scientific corpus here. And here we have the BSc Science and Technology Studies group that comes and say, hey, I want to analyze 200 million of scientific records. That's fine. And we want to check the usage of AI-related methods across fields and years in science. They met with us, and we come up with a pre-process requirement, download, organize, and classify these 200 million of records. We propose 2 AI methods, analyze the abstract of every scientific record, and classify the sentences in their rhetorical role, introduction, conclusion, future work, methods, then get the sentence talking about methods and classify them between AI-related and non-AI-related. The validation were a human validation with a representative sample, but also a prompt robustness. Prompt robustness is a common practice in the machine learning community that we get the same prompt and we make slightly variations just to check that the slightly variation doesn't change the result. And then engineers start working on that, and we found a scale problem. We had 0.9 billion of inference, so the goal here was to reduce the computing cost. We tried to first reduce the model size to see which is the smallest model that works for our use case, and then we start to develop inference and parallelization algorithms more optimized. We ended up with a reduced computing time about 100 times less, and the final computing time was 92 hours in 96 GPU in parallel. And the best point here is that this parallel approach we developed is now reusable for other workflows. And the results, just to show you some good images, here are the first empirical proof of the usage of AI methods in the entire scientific corpus. Here we see, well, in different fields, in different years, and this is one of the first outcomes we get, but we also get some of this because we cross the results with the author's country, and then we come up with these maps that shows the contribution of every country in every year in every field of science in AI methods. And this is an ongoing working publication we are developing right now. Just to show you an example of how HPC's high-performance computing could be useful in social science analysis. And that's it. With our future work, right now we want to improve our onboarding process. We use Jira for the onboarding process, but we want to develop our own low-code interface, just click and drop. We want to make faster testing cycles. That's something that helps because scientists come and want to test the hypothesis in 1 month just to check if it is feasible. We want to improve the validations. Why not adding modern labeling platforms, as Label Studio? And we want to ease the process to pool labor force. Validation and labor force are somehow very important in machine learning, and right now we want to ease this process. For engineers, we want to keep diving in model-driven software engineering. We want to improve the code generation capabilities, to make a transition into domain-specific language, and instead of using pure Python, use a DSL that will help engineers to keep things ordered. And also want to support state-of-the-art AI data methods. You have, for instance, the GraphRag method or RAG developments or synthetic data generation that can be plug and play in the workflows in an easy manner. Finally, just for results, we are right now developing a reproducibility on-demand button on Dataverse, so you can reproduce all the workflow just clicking in one button if you have the budget. Release a stable version of Dataverse. I think we have one stable version yet to release it. And extend the support for CDIF recommendation and for cross-an. And that's it. Thank you very much. And if you have a use case, please contact me.
Thank you, Juan. Any questions? Yeah. Do we have our mic runner? Yeah, right back there.
Hi, I'm Irariani from Stewardship University. Thanks a lot, a very interesting presentation. One question on your charts, the empirical study part. The life sciences, the health, if I'm not mistaken, another one was, just go back to that one. Yeah, this one. So the life sciences, the health, and social science all look almost the same, around the line of between 3 to 5%. It's quite low, and even the kind of physics sciences, that also is, if I see from here correctly, is less than 30%. So can you expand a bit more what's happening here?
Well, in physical science, we have computer science that have a high rate. And that's the result we found, in fact. Obviously, life sciences, social science, and health science are AI adopters. So you are using AI methods. And in physical science, you have both AI adopters and also AI developers. And that's the result we found. But depending on for instance, in business management, you have higher results. And obviously, in computer science, in physical science, you have this 23–30% in 2024. But it leads to another presentation explaining this result, not about workflows. But maybe Merced.
Just to add, because we're collaborating on this project. Tomorrow I will talking a little bit more in the first session in the morning about this project. But yeah, just note though that this is the patterns of an emergent field or an emergent area where AI. The emergence of AI with interdisciplinary with other fields, right? And what happens there is that there is one of the fields within the social science, one of the fields within the life science, one of the fields within the engineering that are really leading, and they are much higher than that average number. But when you add up the scientific production for the entire domain, it's actually relatively low. But as you see, it's also exponentially increasing in the last years. So, in the recent years. But more tomorrow.
More tomorrow.
All right, tune in tomorrow. Thank you, Juan. All right, our next speaker is Gnana Bharathy.
Good morning. So, so this is about AI and advanced analytics infrastructure for Australian healthcare research. And this is about the approach and then where we are heading with that. Okay, so I'm from ARDC, and both myself and my co-author, Adrian, are both work for this. But it also includes a number of other organizations in different parts of that, this program. And particularly, the advanced ARDC has 4 pillars. ARDC has multiple pillars, and healthcare pillar, which is called People RDC, is one of that. And one of the focus areas of this is advanced analytics and AI, and that's what I'm going to be talking about. So I mean, we all know, at least we knew, that there is a need for infrastructure capacity to be built up for healthcare research. But we also wanted to make sure that it is done right. And so we undertook, through a systematic process involving 3 phases: co-design of the framework, an architecture and the roadmap, and the co-investment and the subsequent development. And so this resulted, among other things, in an architecture, or that's what I'm going to be talking about. That's central to today's talk. And this architecture, of course, has many boxes. As we all know, in every architecture, everyone can come up with the boxes. But I would be looking at how and why we are looking at this, and how and why we came to this. So in the beginning, there was co-design. And so co-design involved development of framework, and that framework was done in collaboration with other organizations, including Australian Data Science Network and Australian Cancer Data Network. And the co-design itself involved extensive elicitation through surveys, workshops, and as well as interviews and environmental scans. And this was brought together to identify the needs of the community, the research community. And a number of issues were elicited, and I wouldn't dwell in that except to summarize them, that there is a need for secure compute infrastructure, easy-to-use tools, and AI-ready data, socio-technical resources. So for example, if we were to look at it from the AI lifecycle perspective, at every stage of the lifecycle, there has been some need elicited that include, for example, even in the problem formulation stage, to training, support needs, guidelines, to, as well as in managing the data, managing the sensitive data, and so on. And lack of supporting infrastructure was highlighted, and of course, translation. So informed by these needs, we started developing the architecture. But that's not all. So the architecture itself is organized around the needs. So it compiles different aspects of the needs, but it also includes a number of other aspects in the development process. And, but as you can say, at the very top of the architecture are virtual research environment, and as well as there is room for socio-technical assets, enabling tools, and underpinning infrastructure. So
So development of the architecture process itself looks at about 4 different dimensions. One is the needs elicited through co-design process, and the principles of architecture principles, and the resources that would come from from our infrastructure resources, and all brought together to develop the architecture. And at least initially the candidate architecture, which were refined into the reference architecture. And it was also validated both through the co-design process and as well as in number of subsequent presentations. So if you look at the needs at the high level, and there is the handling of the socio-technical complexity is central. And so it includes, for example, the needs for upskilling, guidelines, governance, and so on. The tools to match the needs, which means not everyone was comfortable with, say, Python. And so that was another aspect. And the secure infrastructure, secure but collaborative infrastructure also came up. And then it aligned with how we define the infrastructure, starting from the soft to the hard to the soft. So there can be underpinning infrastructure such as cloud, reference data, data assets, socio-technical assets, tools, and platform. And a number of architecture principles were applied. And to take a few, modularity, curating, developing, shared infrastructure, and so on, and user-centric design, as we saw in the co-design. But once we have defined the architecture, we were to go and select the projects. That included one to look at the innovation potential of national interest, but particularly ARDC as a national infrastructure developer is duty bound to particularly play in the area of market failure, where which cannot be otherwise addressed. And in addition, the socio-technical complexity also dominates in our work. And of course, being fair to the sector, we will all hear every day, that's also an important factor. So this also brings together another part, which is a trade-off in this. On one hand, we want to be developing for specialized cutting-edge solutions. On the other hand, we want to be also able to provide the most benefit to the largest segment of the researcher population. And so if we were to look at, we were catering for both. And so through this approach, we have we developed architecture and have been phase validating in a number of forums, and as well as testings against individual cases. And so if you can look at this, there are specific projects that emerge from this, and that includes, say, for federated learning, which also came from one of the studies. The cardinal issue of healthcare data, how do we handle the issue of sensitive data management and sensitive data in AI environment. And similarly, the socio-technical assets and the virtual research environment, which is to provide for both, virtual, flexibility and agility, at the same time being able to provide same-stop shop, and also, finally, security, and so on. So these came up with three projects: Federated Machine Learning Network, AI Resource Hub, and AI VRE, and virtual research environments. So it balances multiple concepts, and including privacy, which is handled by federated research, federated machine learning, and the virtual research environment with scalable cloud and so on, which is, and the AI resource hub to actually fit out the virtual research environment. And another, as a demonstration of the power of architectural thinking, we also posited, for example, all the VREs in a continuum, and which enable us to develop it with the same repeatable, reusable blocks, and so on. So these are multiple partner projects, and so this to satisfy the diverse needs of the community. Okay, so this is the impact of this is when it is used in the research, and the projects two of the projects have just started, and one is about to be commissioned in the coming months. And so it democratizes access to AI research and uses co-design approach, and uses a VRE continuum. And yes, so that's where the, yes, I will leave it at that. And I can take any questions if there is time.
Thank you, Gnana. Unfortunately, we're going to need to move on. I don't think we have time for questions at this point, to be fair to the other speakers. So our next speaker is Julie Shi.
Hello, my name is Julie Shi, and I am the Digital Preservation Librarian at Scholars Portal, which is the technical infrastructure department of the Ontario Council of University Libraries in Canada. Scholars Portal and its main data center are based at the University of Toronto, which operates on the traditional lands of the Huron-Wendat, the Seneca, and the Mississaugas of the Credit. And today the meeting place is still home to many Indigenous people from across Turtle Island, and we are grateful to have the opportunity to work, live, and play on this land. Digital services and stewardship extend far beyond physical campus spaces, and I also want to recognize that the data, infrastructure, labor, and impacts of this work extend across many more Indigenous lands and territories than just those on which the university stands. So research data management, or RDM, refers, as many of you probably know, to the processes applied through the life cycle of a research project to guide the collection, documentation, storage, sharing, and preservation of research data. These practices support data discovery and access, reuse for reproducibility and secondary science, as well as research transparency. In libraries, we see these benefits reflected through the development of RDM services, as well as funder and publisher policies on data management plans and deposit. And these RDM goals are articulated through the FAIR principles, which we've talked a lot about so far, and making data fair at the time of deposit is a common goal for curation. Though the principles don't mention long-term preservation, preservation activities are required to maintain fairness into the future. So research data preservation is an established stage of the research lifecycle and refers to the series of managed activities that are necessary to ensure continued access to digital data objects for as long as necessary. Some of these activities map to RDM and curation practices, so we may also think of data preservation as recurring cycles of curation over long periods, which therefore requires thinking about and monitoring a wider range of risks related to file formats and storage media, dependencies, rights and provenance information, and documentation, among many other things. And along with these risks, a close understanding of the data, as well as who is and will be using it and why, is needed in order to make preservation decisions that support continued usability of the data. As such, designing and implementing the practices that would keep data fair into the future is often left to the institutions who take on custodial responsibilities for research data. As a service provider, we at Borealis ask, what is our role in data preservation efforts? Borealis is a national research data repository in Canada that provides shared infrastructure to over 75 organizations and institutions across the country. The service is run by Scholars Portal and supported by the Digital Research Alliance of Canada and 3 regional academic library consortia. The repository is built on the Dataverse software out of Harvard. While the service team provides technical support, Each institution establishes its own RDM policies and guidelines and manages its own collections within the repository. As such, we see the preservation of research data as a shared responsibility between Borealis as the service provider and participating institutions as experts on their institutional context, user communities, and data collections. And we can look at this shared responsibility through the metaphor of a three-legged stool. Borealis commits to providing technical infrastructure for data management and baseline preservation. However, we are not able to define preservation goals for institutions because we're not familiar with their organizational context or the ongoing preservation and access needs for their deposited data. As they've done for RDM, institutions must define preservation strategies, programs, and workflows that make sense for their collections, communities, and financial staff and technical capacity into the future. The Borealis Preservation Plan specifically addresses the technology leg of the preservation stool and outlines 2 levels of preservation. The first level focuses on bit-level preservation and is managed by Borealis for the whole repository to ensure fixity and file management for all uploaded data, so making sure that data remains unchanged in storage over time. This work includes maintaining the platform, This work includes maintaining the platform, although Dataverse is built for discovery and access. Some features do support preservation needs. For example, Dataverse calculates checksums, which we might think of as digital fingerprints, and identifies formats of files on ingest. Citation, descriptive, and provenance metadata are supported, and records are generated using well-known standards, and Dataverse provides version tracking to record data and metadata changes. We pair this with a secure storage and backup strategy. All data files are stored in Scholars Portal's Ontario Library Research Cloud Storage Network, and so at any time, all files are stored on 3 of our 5 storage nodes to ensure continuous access and availability. Data files are also synced to spinning disk and backed up to tape every night for rapid restore and recovery. And the star of level 1 is our monthly fixity checks, which look at the checksums or fingerprints of each file to ensure they remain the same in storage. By comparing the checksums of stored files against the values calculated on ingest, we're able to determine if the fingerprints and therefore the data have remained stable. When a mismatch is reported, we check for a good copy and coordinate with institutions to either replace the file with an available copy or version the dataset to remove the corrupted file. In all cases, we record the reason for and nature of the change in detail. As we saw, level 1 activities only ensure that data remains stable after deposit. Level 2 of our plan encourages institutions to take a more active role to ensure ongoing access and usability based on the needs of their collections and communities. As part of their policies and practices, institutions can request support from Borealis to export datasets. One workflow that institutions can request is the export of datasets as bagged packages to receive a repository-independent copy of published datasets for local management. Exported bags are structured according to the Baggett packaging convention and include all data files as well as metadata records in various formats. Our other supported workflow is the Archivematica integration, which Scholars Portal sponsored to enable institutions to ingest datasets directly from Borealis into the open source Archivematica preservation system. Technology is our bread and butter, but preservation is of course more than that, and support is often needed for the other legs of the stool. As such, we've also engaged in projects to support organizational infrastructure. In 2021, Scholars Portal collaborated with the Alliance to run a CORTRA Seal certification project. CORTRA Seal, or CTS, is an international certification recognizing digital repositories as trustworthy, and requirements are renewed every 2 years. During this project, writing sessions and workshops were organized for a cohort of Borealis institutions to learn about CTS, develop policies, share knowledge, and prepare applications based on the 2020 to 2022 requirements. Template policy and application documents were also created and informed the development of the Borealis Preservation Plan and related policies. This past year, we worked with the Alliance's Preservation Expert Group to refresh and expand the templates based on the 2023 to 2025 requirements. This work responded to requests from the Borealis community for more preservation supports, as well as a key change in the certification's preservation requirements, which reflects the fact that maintaining fixity alone does not guarantee long-term access, understanding, or usability of data. Some Borealis institutions that had applied for CTS following the earlier project had also received feedback recommending that they demonstrate more clearly that preservation is an institutional and programmatic commitment, rather than a purely or primarily technical endeavor. So these changes and comments were incorporated into the templates, and the new documentation suite was released in July with 5 updated policy templates and a new application template, which is pictured on screen, a little small. And for our latest project, our intern has been investigating how Dataverse identifies file formats and how well the platform performs compared to digital preservation tools like Droid and Siegfried, which identify formats based on internal structure and other means. Detailed format information helps institutions determine how usable and accessible a file is and what interventions are needed to ensure fairness into the future. Dataverse identifies formats by MIME type, which tells web applications how to handle content that they receive and send. These MIME types are mapped to human-readable friendly types in Dataverse, but neither of these provide enough detail for preservation. For instance, Dataverse identifies this as a Microsoft Word file, but which of these 17 format versions is it actually? What version of Word and what operating system do you need to open this file? All in all, preservation is very much a work in progress among the Borealis institutions. In 2023, institutional administrators rated bit-level preservation support as one of the best service features. However, only a small number offer additional preservation processing using level 2 activities, and few have a public preservation policy for their data repository. Comments also suggested that some institutions rely solely on Borealis for preservation or backup. Institutions are at various stages, though, with the University of Victoria in British Columbia and the University of Manitoba receiving CTS certification this past year, and both reference level 2 activities in their applications. So digital preservation takes time, and there are many challenges along the way, including developing the skills and knowledge to do the work, securing sustained funding and support for training, creating and implementing workflows, developing documentation and policies, and that's just to name a few. But it's also an exciting journey. Research data preservation presents many opportunities for collaboration between RDM services and digital preservation programs, and with infrastructure and service providers, other institutions, and researchers. In Canada, we're also envisioning and exploring national models for supporting preservation work. As we start and continue on our preservation journeys, I would just close with whatever stage you're at, do what you can, one building block at a time, to support fairer data into the future. And while it's just me presenting here today, these efforts are the result of years of work and time from many dedicated people, so a big, big thank you to all of them, and thank you all for your time.
Thank you, Julie. One very quick question. All right, I think we will move on then. Thanks again. So our next speaker is Juvetje Blumen. I probably botched your name. Oh, it's a co-presentation. They'll introduce themselves.
All right, yeah, thanks. So yeah, we might be an odd one out because there's two of us, so you get 2 mini talks in our time slot of 9 minutes or something like that. And also there are two bit different topics. I mean, we do have AI projects at our university, but we are not sharing them with you in this talk, unfortunately. So sorry about that. I'm Joan Philips. I'm the research data coordinator of the University of Leuven in Belgium. And my colleague Diewertje Bloemen will talk about supporting data curation to automation at the university. I will briefly bring the context about what kind of RDM services we do at our university. So it's been a journey in our institution in the past 10 years, especially the last 5 years. We've really increased our support for RDM services, and it's a joint effort with many different divisions in the university. So we have the libraries, we have the research office, the research coordination office, we have the IT department closely working together, but then there's other parties like the legal department, the tech transfer office, or in internal RDM support at different levels of the institution, at the faculty, at the department, but also at research groups. And then we try to bundle all this people or all this support through our competence center, the RDM competence center, that has a joint action plan and joint services that are involved in all these divisions. So, okay, yeah, and then other governance structures as well at the university to streamline all these things and go from policy into the implementation of our services. So what kind of service do we offer at the university? We talk about a holistic approach because it's a joint effort between these different divisions and different teams, and we form a network at the university to try to answer from each RDM challenge we have or the researchers have to a spectrum of services. And from the top to the bottom, it's basic support to more advanced support, where we have a help desk, where we have organize training sessions every year. We have about 30 different training sessions. We do DMP reviews, support for data publications in the institutional repository, but also offer training on demand, policy support for faculties, and have one paid service where we have a book data manager service that research groups can hire one of our data managers for a particular challenge they have in their research group or project. So next to these services, we also have a lot of infrastructure projects. That's coming up now. Yeah, there we go. So we try to offer infrastructure and tools at each stage of the research life cycle. So that means from the start to the end, when you're writing your DMP, or when you're actively doing your research and you want to manage your data during the active phase of your project, or at the publication phase where you want to deposit your data sets, or long term when you want to preserve or archive your data. And for every, there we go, we're a bit too fast, yeah, now it's there. So and for every new infrastructure, we try to look at doing open science through open source. So we try to use open source software as much as possible in our new infrastructure developments. And for instance, for the active data platform, we're using Mango, which is based on IRODS, the IRODS open source platform. And for our data repository, Radar, we're using Dataverse, as the previous speaker also has in their institution. We try to build upon these open source platforms, and also try to give back the RDM work that's been built upon it to that community, so that we share our things with it. And that's my part of the talk, and I'll give the floor to Dibutje.
Yeah, thank you. So to go into a bit of a use case that combines this network that we've built of RDM support with the infrastructure that we've built is our review dashboard, as we call it, which is sort of the next step. So we've built this network over the last couple of years with these basic parts of our infrastructure, but now we're trying to optimize it through automation. And we want to do that to support our researchers, but also to support our support staff. So as Joan already mentioned, we have a Dataverse-based repository, which is Core Trust Seal certified. And we have a review phase in there where each data set gets reviewed. And the goal is, on the one hand, to make our data as fair and as open as possible, but to also teach our researchers how to publish their data well. Everything that gets reviewed in Dataverse normally is quite manually. So you have to type in your feedback. There's no tracking of who reviews what and when, and there's no tracking of previous issues. So if you send the feedback, you hope you remember what you sent. Most of the time, you don't. So we built a review dashboard a couple of years ago, I think about 2 years ago, with the main purpose to track who reviews what, to avoid overlap, save previous reviews and checks so that we can know what we said last time, and so we can enable unified advice and messaging, because we noticed that we were just copying, please add a README file, this is a README file, how do you write one, again and again and again. So maybe it was easier that that message just got sent automatically instead of us having to copy and paste it in every time. So the key features were that assignment of reviewers, that we can see who reviews what, a checklist of items to review, a note field, because reviewers can always come up with things that you never expected them to do in a data set, and auto-generated feedback based on a checklist. This is what it looked like at the time. So you just see your data sets that are in for review. You can see here, for example, Laura is picking them up, and then you go to the review data set, you have a checklist, you have a notes field, and then you have an overview of what you indicated what was maybe an issue there, and then you have an email that gets generated based on the notes, based on the checklist, and you can edit it before it gets sent. Now, that was a first iteration. We've been working with this dashboard for about a year now, I would say, and it's quite nice, but there's more to be done. Like, we can automate more. So we decided to explore and look out, and I think this especially came up from a lot of conversations around AI during conferences, so we thought maybe we can use AI in our reviews, and we did consider it, but once we started exploring the AI options, we realized we can actually automate without AI, because I think that's an important thing. When you do look at AI, that's not only the only solution to automate. So when we were looking at automating reviews, we really wanted to be able to highlight issues and risks through warnings, because there are certain things that sometimes happen that aren't super visible that you really have to pay attention to find. And we also wanted to decrease the chance of mistakes if there are certain things that we can automate, we can check with simple scripts. So what we added onto the dashboard are automated checks with an indication of status, a script per check, because this dashboard is an open source and we want other people to be able to use it, but they might not use all the checks that we do, so they should be able to turn stuff on, others off, or they should be able to add on new checks. And there's also the option to compare between what the other checks found and what you yourself might have found, and what if they contradict each other. It should be possible to manually override it. So that's what we did. Here's an example of a data set that I made with some issues in it. So the description here is too short, there's no license selected, a file extension is missing, which is not always a problem, but sometimes it is, or researchers just like to remove .csv, I don't know why. And here you see a README text. Great, there's a README, but it's actually empty. And to move on to that, here you don't have an ORCID. Keywords are entered incorrectly. It's not very easy to see that here. And here, there's actually no DOI field filled in, even though we can see that there is a DOI. And they said it's embargoed, but there is no embargo date. These are all things that we can automate. So here's one that was run, and you can see here the status. So the checkboxes are the manual stuff. The checks, the other checks are in front of it, and here you can see the warning that there is a README, but the README is pretty much empty or entirely empty. And these are the kind of things you can do. So I don't know, yeah, so here the other check was run, and then I can click on apply all other checks, and it just copies in the things that were correct. And then I move on and can provide the feedback. Moving forward, because this is a first step of automation, we want to continue to support more data steward processes through automation. This is just a use case of one of the many processes that our data stewards have to go through and work on. And we wanted to continue to include exploration of AI where relevant. As you see here, it's not as relevant maybe as somewhere else. And we also want to continue to balance the automation with the human intervention and insight, and explore options to provide also these auto checks as a pre-check tool for researchers, so that researchers can kind of do a pre-review before they submit. So yeah, that was it. Thank you very much.
Great, thank you. One very quick question. We're running a little behind. You need a mic.
I think this work is very great, and I think the most challenging part of your work is how to ground the specialized vocabulary of the research data to the base model of the large language model. Because the large language model may lack of the specialized knowledge of different domains.
Yeah, so here we didn't use AI specifically, but I think one of the things that we do before we look at AI implementation in the RDM support is to do proper research into what is actually possible. It's actually a project that Joan worked on last year, which is related to one of the other presentations to do with DMPs. And there they explored what was possible. And I think one of the conclusions is indeed that it's quite difficult for domain-specific advice, but there is RDM advice that's broad enough that I think you can do a lot with already.
All right, thank you very much. Thank you both.
Thank you.
And our final speaker is Michaela Miller.
Hi, everyone. I also know that I'm standing in the way of lunch, so I will be as brief as I can. I'm going to take everyone south a bit and talk about the Southern Ocean, so just prepare yourself. To begin, I'd like to start by acknowledging the Palawa people of Lutruwita, or Tasmania, as the traditional owners of the land on which I work and live. I'd also like to acknowledge the Turrbal and the Yagara people of Minjin, as the traditional owners of the land that we are currently on today. And I pay my respects to their elders past and present, and would also like to acknowledge that sovereignty was never ceded as we gather on stolen land. So as a brief overview, I'd like to state the mission of the Southern Ocean Observing System, or SOOS, as I like to refer to it, and we like to refer to it from here on out. Our mission is to facilitate sustained collections and delivery of essential observations of the Southern Ocean to all relevant stakeholders through the design, advocacy, and implementation of cost-effective observing and data delivery systems. So one of the main ways that we do that is providing a product called SOOSmap. And so I'm going to start by going over just the back-end side of things. What we have in place for data in the blue over there is essentially, we have both manual and automatic entry points of data, both into either a GeoServer or an ERDAP server, depending on the type of data that they are. And then these get passed on to either Web Map services or exported as a GeoJSON and then pushed onto SOOSmap. For metadata in the pink, we have manual entry for the data sets that sit within ERDAP into the content management system. It's a user face that kind of just eases the editing of ERDAP metadata. So you don't actually have to go into the file itself. And once that's entered or updated into ERDAP, this is at the moment manually exported and moved across into our GeoNetwork or metadata repository. And for the data sets that are in GeoServer, this metadata goes directly into GeoNetwork, which is then linked up to the GeoServer as well. And all metadata that sits within the GeoNetwork, so there's a record for every single data set that we have, that's automatically pushed up to SOOSmap. So during these initial phases that I've highlighted here with the red arrows, there's several things that we do to ensure that SOOSmap complies with the FAIR data principles. So to ensure our data are findable, we host all of our metadata for each data layer within SOOSmap on a public GeoNetwork catalog. Each record has been assigned a UUID that will never change and contains detailed metadata as well as links to the source metadata where that information came from, the source data, so you know where the original source of the data is hosting their data, as well as the data within our own ERDAP and GeoServer. We provide links to those as well. All data and metadata within our GeoNetwork and SOOSmap portal are accessible publicly and openly to everyone. There's no paywall or login needed to access these resources. You can go on and see everything that we've got. To ensure that data and metadata are interoperable, we conform to several standards that we implement. These include applying like CF conventions, ISO 19115 standards, and also some GCMD keywords, which will help with data discovery as well. And then lastly, when grabbing the data and metadata, we ensure that the source is providing as much detail as possible to ensure the data are then properly used by the end user. And also be able to be integrated into either global aggregators or used by those community members that need it. If details don't exist, we either work directly with the data providers to obtain that information, or if that's not possible, sometimes it's not, we point users to additional resources like project web pages, methodologies that have been published, or a point of contact for them to reach out to those data providers themselves. So the best ways to access data and metadata for those within SOOSmap are first and foremost the SOOSmap portal that we have for data visualization. So if you're interested in doing a deep dive into the metadata, we've got our public GeoNetwork repository for you. And once you've discovered the data you're interested, we also promote using programmatic access to those data sets that are in ERDAP or GeoServer directly, and have a public GitHub that contains notebook demonstrations and examples on how to do this. So I'm just going to run through very quickly an example of SOOSmap for you so you can kind of get an idea of what the portal looks like and how one might use it. So the SOOSmap portal, it's recently been updated to improve functionality and data visualization. Our version 2 is now launched in the last couple of years, and we're quite proud of it. There's definitely a lot of places we need to go still, but we're quite proud of this one. So on the homepage here, you've got several key sections that you can kind of play around with. Up the top, we've got a video tutorial to walk you through how to use SOOSmap for new users. We're also in the process of updating this. If you've got background layers that you would like to toggle on and off, over there on the left side of the screen, and on the right, you've got a filtering matrix, so you could find the data sets and data products that we make visible. So you could filter those by platform type and also key variable. And so now I'm just going to walk you through an example. So let's say, oh, that's quite small, sorry. So let's say you're interested in plankton distributions and abundance in the Southern Ocean. Let's just play along for a second. I know we're all data people, but let's say you're interested in plankton distributions and abundance in the Southern Ocean. To begin, you might want to see where efforts have existed before. So where has that data on plankton been measured? How often has it been collected? You know, because you're a very smart researcher, that it's often collected while you're on research vessels. So you head over to the filter matrix and you click on the data from SHIP's platform. You can see the data is produced by the Australian Antarctic Division and their continuous plankton recorder. Then you could visualize these data by clicking the eye icon and then place them on the map. And if you want to see the metadata, you could hit the info icon and that will trigger a pop-up providing details. So while in this section, you could also see that the British Antarctic Survey has also produced a long-term database focused on plankton, which is fantastic. Clicking on that eye icon again will overlay these data on top of the Antarctic Division data. And so you could see kind of where sampling efforts overlap, or more clearly, you can see where gaps exist in those data. So now, again, because you're a very knowledgeable scientist, you know that plankton and dissolved organic matter often have a complex and cyclical relationship. Obviously, everyone knows this, right? So as a smart researcher you are, you'd also like to understand if there's any dissolved organic matter or DOM data that has been collected in the same locations as that plankton data. So after looking at the data sets on SOOSmap, you have just going through all of the different data cards that we've got. You could see that NOAA from the US has actually produced a large data set of DOM observations, which you can toggle on, and you could see some key areas of overlap. Then to investigate the data further on the portal, you can click into data points, which provide a pop-up with key values and information. And essentially, you could click around on the map and see the details of the different data sets that you've put up. For some data, when you click on them, depending on the types of data that they are and their source, you have the possibility of plotting key variables directly in SOOSmap to visualize the data quickly to make sure it's what you want. And if you'd like to download the data for all the layers that you have visualized, clicking the download icon up the top will provide you with the links to access all of these data and download them directly. Alternatively, as I mentioned before, we've got links via the GeoNetwork metadata record for each data layer so you can access it. Or if you like programmatic access, you can use the ERDAP URL directly, which again, we provide an example on our GitHub demonstrating how to do this. Lastly, while I've just got a minute here, I'd like to self-plug the fact that we are currently recruiting for the Data Management Subcommittee, so the governing body over all of our data activities in the Southern Ocean as part of the Southern Ocean Observing System. And so if you are interested in that, or you know someone that might be interested in that, please get in contact. And yeah, that's me. Thanks so much.